salt, a solute, and water make a solution. We discussed that we knew it was a solution, or we knew the solution was saturated when salt formed at the bottom and no longer dissolved into our solution. Today our question is, how much salt really did it take to saturate this solution? We know how many scoops we put in, but did every grain of every scoop dissolve into the solution? I'm guessing not, since there's still salt at the bottom. How can we figure out exactly how much salt it took to saturate this solution? In order to figure out how much salt is dissolved in this water, we first need to get rid of the salt that didn't dissolve. In order to do this, we're going to use the same funnel system that we used to get the salt into the bottle, but this time we're going to use it to filter the salt out of the solution. You're going to start with a coffee filter that you fold into fourths. Open up one of the sections and put the filter down into your funnel. Now carefully pour the solution from your bottle through the filter so that it filters into a cup that you've placed below. What's filtering out is the water with the salt dissolved in it. What will be left in your filter is the salt that didn't dissolve. My solution has finished filtering. What's left down below is salt water. The water and the salt that was dissolved in it filtered through the filter. What's left in my filter is the salt that wasn't dissolved. This is the salt that was already in the bottom of our container. The salt with the water goes through. The salt that wasn't dissolved is left behind. For this lab, we'll be using a pan balance. We can place an object that we want to know the weight of on one side and add weights to the other side until it balances out. In order to begin, we need to make sure the balance is level before we add anything to either side. As you can see, when we put 50 milliliters of water on one side, it took 50 gram pieces to make the balance level. I can see that my original 50 milliliters of water and my new filtered salt solution do not weigh the same thing because the balance isn't level.
Our next step is we're going to talk about the scientific principle of conservation of mass. What that means is the 50 milliliters of water weighed 50 grams. Each and every gram of salt that was dissolved with the water is still 1 gram. It weighs 1 gram within the solution. So your task is to find out how many grams of salt dissolved in the water. And so you will add gram pieces to this side of your balance until you get it to equal out. The number of grams on this side will be the exact amount of grams that dissolved in the water because the mass has been conserved. It does not change. For example, since we started with 50 grams with our 50 milliliters of water, if 10 grams of salt was able to dissolve into our solution, then I should be able to add 60 grams to this side, 50 grams for the original 50 milliliters of water, plus 10 grams for the salt that has been dissolved in our solution. In the next lab, you will need to figure out how many grams of salt have dissolved in your saturated salt solution and saturated citric acid solution. So go back to your data, find out how many scoops it took to saturate your salt solution, add that many. You don't need to add one at a time. Saturate your salt solution and filter it using your filter system. Then, using your balance, weigh it to find out how many grams of salt dissolved in your water. After that, you'll go ahead and do the same thing with your citric acid solution. Go back to your data, find out how many scoops it took to saturate your citric acid solution. Be sure that you let the citric acid solution rest for a few minutes to make sure it has time to fully dissolve into the water. Then go back to your balance and use the same process to determine how many grams of citric acid dissolved in the 50 milliliters of water.